Okay. So we start. Last time we were on question number 2. I couldn't do this number 2, but I've tried to download a smart notes. So I'm gonna try and open it and see if I can work with that one. All right.
Yes.
So I've done a screenshot. So let's start. So let me open this. All right. Can you see the smart note there?
No.
Yeah.
Where, sir?
No, sir.
No.
You don't see it. Best.
Yes.
Can you see it?
No.
We can see the work, sir, but we don't see those.
The notes.
You don't see 2 pages that are split like that.
No.
Okay, let me do new share. Okay, my system is slow. Okay. Can you see it now? Can you see it now?
Yeah.
Yeah, now, yeah.
Okay, all right. So my system here is saying it's unstable. I'm not sure how it's going to end up here. Okay, so this question here says, very slow. Okay, so it says here, it says a group of learners perform an investigation to determine the charges on each of 4 objects. I've got Q, R, S, and T. They use an object X with a negative charge as well as a neutral object, right? So we start with P. So I've got P, right? Then I've got a Q, or maybe the best way to do, let me write it here. All right, I see my system is not stable here. All right, so it says observation Q attracts P. So it means the charge on Q and P is not the same. All right, so they are opposite charges. Then R repels Q. So it means Q and R have the same charge because they are repelling. S attracts R but repels T. So S and R have got opposite charges, right? And S and T have got same charges because they are repelling. Then you have got T attracts X. So if you go back to the statement here, you are told X is negative. X is negative. So now what are you going to do? You're going to say X is negative. So X is negative. All right? If X attracts T, then it means T is positive. So T is positive. Is positive. So you come here, it means this one is positive here. T is positive. All right? Your T is positive. Are you following? All right? Then it says S attracts R, but repels T. So we know T is positive, and we know S repels T. So it means S must have the same charge. So S is also S is positive. S here is positive here. S is positive. So we're gonna come to the table here and write here S is positive. All right. So T and S have got the same charge. That's why S is repelling T here. Right? Then we are told S attracts R. S attracts R, right? So it means if S is attracting R, they've got opposite charges. So if S is positive, then it means R is negative. So R is negative. All right? R is negative. So we come here, R is negative. All right? Now, we are told here, observation 2. We know R repels Q, but we know R is negative. We know R is negative. So if R is negative, repulsion is because the charges are the same. Therefore, it means Q is also negative. Q is negative. All right? So your Q is negative here. All right? Then I think everything is answered. Even the first statement says Q attracts P. All right? We don't even have the P. So our Q is a negative, and we're told that P is neutral. So that could be due to polarization there, right? Because our Q is negative. So back to the table for 8 marks. You have got your Q is negative, your R is negative, your S is positive, and your T is positive. That's how you get the answer. So you work backwards. So you start with this statement here. Observation 4. T attracts X, and we are given the charge of X from the statement here, where it says they use an object X with a negative charge. So it means X is negative. Attraction means T and X have got opposite charge. So if X is negative, T is positive. Then you go to observation 3. S attracts R. Attraction means opposite charges, right? So it means S and R have got different charges, right? Then S repels T. S repels T. So it means S and T, they are repelling. They've got the same charge. But we know T is positive. Therefore, S is also positive because of repulsion between S and T. Then, if S is positive, then it means R is negative. Then you go to observation number 2. R repels Q. So if R is negative, right, repulsion means same charge. So it means R and Q have got the same charge, which is negative. Then we have answered the question there. Right? Are we clear on this one?
Yes.
Okay. Then the next one that I wanted to explain here, it says, this one I think we spoke about this. Let me just run it, go through it for the benefit of people who are not here. All right, two small spheres, sphere B and C on insulated stands carry charges of 3 times 10 to the power negative 9 coulombs and negative 6 times 10 to the power negative 9 coulombs respectively. So the other one is positive because of the plus, and the other one is negative because of that minus. So one is positive, one is negative. 2.2.1, how does the number of electrons on sphere C compare with the number of protons on sphere C? So sphere C is this one. We've got a negative, all right? So negative means there's more electrons than protons. So how does the number of electrons on sphere C compare? So the answer is more than, because it's negative. That's why we've got a negative charge. There are more negatives than positive. Hence, the overall charge is negative. Then we go to the next one, 2.2.2, give a reason for the answer. The answer there is because it's negatively charged. Negatively charged means there are more electrons than protons. Then you move on to 2.2.3, calculate the number of electrons on sphere C, number of electrons. So for you to do this one now, you're gonna use your equation. Your equation is what? Number of electrons, we use Q. I wanna write here. Okay, my system. Okay, so we have Q. We've got Q. Right, Q is equal to N QE. Right, where QE is the charge on an electron. Right, so we've got your QE there. I hope you can see what I'm trying to write here. Okay, my system is a bit slow, and I'm also using a mouse. So you're gonna use this equation here to get your number of electrons on C. So you've got the charge is -6. You've got your negative 6 times 10 to the power negative 19. I can't write nicely here, guys. You've times 10 to the power negative negative 10. Okay, you've got negative 19. You've got your negative 19 there, right, is equal to n. We are looking for n. And we've got our QE. QE is the charge on an electron, which is negative 1,6. Negative 1,6 times 10 to the power negative 19. All right, I won't be able to write this here. So it's your negative 1,6. All right, 1,6 times 10 to the power negative 19. That's what I have there. Then you make your n the subject of the formula. Your n, right, is equal to, you're going to divide the 2. You're going to divide your negative 6 times 10 to the power negative 19. Right, negative 19 there. Then you divide, right, you divide by negative 1,6. Negative 1,6 times 10 to the power times 10 to the power negative 19. Right. Right. Then after you've done that, you put it on your calculator, then you write your answer, your final answer there. That's how you do this question here. All right. Then the next one, this is a negative here, so don't confuse with this one. But I think you get the gist of what I'm trying to show there. Okay. Then we move on to the next question. Next question. Okay, my system is slow. Okay. Let me just open the other document there. Okay. This is very slow. Okay. Okay, so this is the question that I was doing here. All right. Then the next part, it says the spheres are allowed to touch, after which they separate again and return to their original positions. So state the principle of conservation of charge. So in an isolated system, the total amount of charge remains constant. All right, that's the principle that you need to list there. In which direction are the electrons flowing while B and C are in contact? Right, down from B to C or from C to B. Right, so this is C here. Right, C is the one that was negatively charged, and this one was positive. So the one that is more negative, that's the one that will give electrons to the one that is more positive. So electrons are going to move from the one that is more negative, which is your C up here. This is more negative. There are more electrons here since it is negatively charged. And this one is positively charged. It means there are more protons than electrons. So here there's a deficiency of electrons here. Here there's an excess of electrons. So you're going to have to, your answer is going to be from C to B. So electrons are moved from the one that is more negative to the one that is more positive. There's a case where you're going to get both answers are positive. right? When both answers are positive, you need to check which number is more towards the negative side on the number line. Let's say I had my 3 and I had a 4. So I had a +3 and a +4. Which one is going to lose? Electrons are going to move from the one that is more negative. So between 3 and 4, which one is more towards the negative? It's your 3.
3.
So 3 is going to give electrons to the 4 because 3 is more negative than the positive 4 on the number line. So electrons will move from the +3 to the +4 simply because 3 is closer to 0, closer to negative on the number line than the +4. Clear?
Sir,
Yes.
so what about positive? Doesn't protons also like move, get
No.
transferred? Or is it just
Basically, what it means when you say +3, we are not saying they are only protons. What we are saying is there are more protons. There are more protons than electrons. That's what it means. So here we are not saying protons are moving. So the +3 maybe it's because there are 10 protons and there are 7 electrons. So the +10 and -7 will give us a +3. But it does not mean it's only positive. It means the net charge is a +3. There are also protons, there are also electrons. So what is basically is going to happen is those 7 on the example that I'm giving, the 7 electrons, some of them will move to the other object. So maybe out of the 7, what are we going to have? We're going to have maybe, let's say 2 move to the other side. Then we are remaining with 5 up until the charges are the same. Then you have got your repulsion and they separate again.
Oh,
Yes.
okay.
Okay. Right. So the answer there is the answer it will be from C to B on this question. Yeah, it's from C to B. So it's that part there. Give a reason for your answer to question 2.2.5. Why are electrons moving from C to B? It's because C has got excess electrons than B. So that's why the one that is excess electrons will give the other object. Clear?
Yeah.
Right, then the last question there, it says calculate the charge on each sphere after they have separated again, right? The charge after they separated again. So what are you going to do? You're going to go, I cannot write this, right? So what is going to happen is you're going to add the 2 charges. So you're going to add +3 times 10 to the power -9 plus -6 times 10 to the power -9. So you're going to add the 2. So it's like a +3 and a -6, which is going to give you -3 times 10 to the power -9. All right. Then you divide everything by 2. All right. Your answer is going to be -1,5 times 10 to the power -9. That will be your answer. So each one is going to be negative. So the charge here, each one is going to be -1,5 times 10 to the power -9. That's what you get. Basically, you're using that equation there, Q1. You're using the one that we have here. You're using this. Q is equal to Q1 plus Q2 divided by 2. So you add the 2, then you get your answer. Clear?
Yes.
Right. So that's the question that I
So,
could repeat. Yes.
so what do you call that sign, sir?
Which
That
one?
like you see, if you go just like if you go a bit more up, sir, it's like a
Yeah.
sign. I think it's a U or C or something like that.
Oh,
After
okay.
you've done the calculation.
Oh, the U.
Yeah.
Yeah, that's a micro. Micro means 10 to the power -6. Remember what we did in class? I said milli. What is milli? 10 to the power -3.
Yeah.
Then micro, 10 to the power -6.
Oh.
Then N, small letter N nano, 10 to the power -9.
Oh. Okay.
Then P becomes your 10 to the power -12. That is when your answers are below 1,
Yeah.
less than 1, between 1 and 0. Then if they are greater than 1, you've got your kilo. Kilo is 10 to the power 3, which is 1,000. Then we've got mega. Mega, it's a million, so it's 10 to the power 6. Then you've got giga. Giga, 10 to the power 9. Then you've got your tera, 10 to the power 12. Clear?
Yes.
Right. So that's the one that you have there. Okay. Any other question?
No.
Okay.
I don't know.
So this is what we did last time. Then there's just one thing that I just want to clarify on this example here. I think there's a kind of confusion in terms of the charges. So let's just go over this. It says, with the example, two identical metal spheres of different charges. Sphere 1 is a charge of negative 9.6 times 10 to the power negative 18 coulombs. Sphere 2 is 30 excess electrons. If the two spheres are brought into contact and then separated, what will each have? How many electrons does this correspond to? Right. So let's go over it now. So you've got your data. What do you have? You've got a charge on one of the sphere, negative 9.6 times 10 to the power negative 18 coulombs. And sphere 2 is 30 excess electrons. So the charge is being brought about the excess electrons. Remember, if the other ones are canceling each other, then they don't have effect net charge on the object. All right. So here, you move on, analyze the problem. So you need to check what we need to do on this. So we need to determine what will happen to the charge when the spheres touch. Right? When they touch, what do? They share electrons up until the electrons are equal, or up until the charge is the same, then they repel. They are metal spheres, so we know they will be conductors. This means that the charge is able to move, so when they touch, it is possible for the charge on each sphere to change. We know that charge will distribute evenly across the two spheres because of the forces between the charges. All right. So we know like charges attract, that's why they're coming together. And we know unlike charges, they repel. So after sharing electrons and they have the same charge, they will repel. We need to know the charge on each sphere we have been given. All right. So first of all, we start. The first one, object number 1 is fine because we are given the charge. But the problem is the second object where we are told that there are 30 electrons or 30 excess electrons. So we need to calculate its charge. So this problem is similar. Okay, this time we have to determine the total charge given in a certain number of electrons. We know that charge is quantized, all right? And that electrons can carry the base unit of charge, which is negative 1.6 times 10 to the power negative 19 coulombs. So what do we need to do? We need to calculate Q. How do you calculate Q? Q is equal to number of electrons minus the single charge on an electron, all right? Please note here, the 1.6 is the same charge on a proton. The only difference is the plus and the minus. Electrons are negatively charged, so if we talk about electrons, we use a negative. If we talk about protons, we use a positive, but the number is the same. So we're going to substitute, there are 30 electrons. So where there's N, we substitute with 30. Multiply by the charge on a single electron, which is negative 1.6 times 10 to the power negative 19. You multiply the 2, you get your 4.8 times 10 to the power negative 18 coulombs. So C is the unit for charge, which is coulombs. Then after that, we now go back to the two objects. They are touching. So touching means they are sharing electrons. We want to know the final charge. So what are we going to use? We're going to use Q is equal to Q1 plus Q2 divided by 2. The initial charge we have, which is negative 9.6 times 10 to the power negative 18. Please don't ignore the charges. You need to include the charges here because we want to know at the end of the day after adding, is the final charge going to be a positive or negative? Then we take the answer that we got here. This answer is a negative answer here. There's a negative short on this calculation here, but here the negative is there, so it's fine. So we're going to add the 2, all right, divide by 2. Then we get our answer. Our answer there, it's a 7.2. Let me just double check if this is it's a positive or it's a negative. Let me just check here. I've got negative 9.6. Come again? Someone is talking? Okay, I just want to verify that negative 18 plus.
No, sir.
We've got negative 4,8, negative negative 18, all right, divided by 2. Right, this answer is supposed to be a negative here. There's a negative missing here. There is a negative. So because we are adding two negative numbers, our answer must also be negative. So that's wrong here. So this one must be a negative here. All right, so there's a negative missing here on this one. I will rectify it on the on Google Classroom. If you downloaded it, you have to discard that one so that you save the correct one. Right, so each sphere now is a negative 7,2 times 10 to the power negative 18. So this answer is supposed to be a negative, right? We know that charge is quantized and that electrons carry a base unit of charge. So the charge here is the total charge of all the electrons. So what we're going to do now, we're going to go back to this equation here, and we are using which equation? Q is equal to NQE. So our charge, the total charge is negative 7,2 times 10 to the power negative 18, which is that one there. Now here there's a negative sign, so this one is correct here. Divide by a charge on a single electron, which is negative 1,6 times 10 to the power negative 19. All right, you divide the two answers, then your answer becomes 45 electrons. So the electrons that are on this charge here, it's 45 electrons. That's how you get the answer. So please, just clarity there. Here there is no positive here. It's supposed to be a negative. There's a negative missing for the two to cancel out. Right, any questions?
Sir.
Yes.
Yes, sir. So that 45 electrons, is it the total electrons between both of the spheres?
No. Remember, when they were sharing electrons here, all right, this one originally it was negative 9,6 times 10 to the power 18, right?
Yeah.
Right, then the other one was negative 4,8 times 10 to the power negative 18. So they had different charges. Okay. Now, when the two objects came together, right, they were transferring electrons, they were sharing electrons. Are we together?
Yes.
The one that is more negative gives electrons to the one that is less negative. So electrons moved from the one that is negative 9,6 because this is more negative. So it gives the one that is less negative. So electrons moved from the 9,6 to the 4,8. Right, during that transfer, why are they transferring? Because they want to have equal charge. So the moment the charge is the same, then they repel. So what is that equal charge that each sphere now has after sharing? That's the answer that we have, which is 7,2. It's negative 7,2. So this is for both objects, both spheres.
Yeah, individually.
Is it clear?
Yes. So the 45 electrons is for both spheres.
For both spheres, yeah. Yes. So yeah, so each sphere now has got excess electrons of 45.
Oh.
And these are not the electrons that are there. It's just the ones that are resulting in there being a negative charge. So the number of electrons might not be 45, it could be more than. But the ones that are not canceling or that are extra above the protons, that's the 45. Yeah. So it could be there's maybe 100 electrons. There was 100 electrons and 100 protons. But the 100 electrons and the 100 protons, they cancel each other because positive and negative, they neutralize. Are you following?
Okay. Yes.
Right. Now on the electrons, the 100 that are neutralizing, that are being neutralized by the protons, there's extra 45. So now there's 145 electrons and there's 100 protons. So the 100 electrons cancel out with the 100 protons. Then we've got 45 extra that are resulting in a charge of negative 7,2 multiplied by 10 to the power negative 18. So those are the extra electrons.
Okay.
Yes. Okay. Right. Any other question? Right, so that's what you have. Then the activity there, I'm not sure. How did you find this activity here? There was a mistake in the last one, and I tried to correct
Yeah.
it.
Yeah. But so I got a problem when I was confused by question 1.2 and we had to draw.
The 1.2 is just where the rod and the sphere, they are far apart from each other. Draw diagrams to show the rod and the sphere when they are far apart from each other, the rod and sphere when they are close to each other. Okay, let's just check here. A glass rod is positively charged by rubbing it with fur, right? The rod is held near neutral graphite coated insulated sphere, which hangs freely. So basically your diagrams, what you need to do, just to show the rod is positive. Let me just see if I can open the whiteboard there. My system is a bit slow. All right, let me see if I can open this. Right, so on the whiteboard here, let me see if I can write here. So basically what you have, you just need to draw. You just need to draw an object, right? You're gonna draw your object there and just show it with the charges. Just show the charges. The other one is positive. So you just have something like that, positively charged. Then you've got your sphere. You've got your sphere there, right? Your sphere is neutral. So you just have maybe, just choose how many, positive, negative, something like that. I think the question there, now when I bring this closer here, what is gonna happen? When I bring this closer, it's positively charged. Positively charged, what is gonna happen when I bring this closer? When it's closer,
It's gonna take the negative.
When I bring it closer, what is gonna happen to this neutral object? It's gonna be polarized. What is to polarize? If this one is positive, it means all the positives here, they'll be repelled. So the positive go far away from here. So you're gonna have your pluses crammed in one side here. So those three will go that side. Then your negatives here, they'll be attracted. So this is what you call polarization. So your negatives will come this side, and this is the kind of diagram that you're gonna be drawing. So you're just showing there, when you bring a positive charge, what happens to that neutral object? When they are far away, what happens? When they are closer, what happens? This is just, you don't have to specify the charges. As long as there's a positive charge, you can make 2, you can make 1, whatever. But as long as you illustrating the concept, then it's fine. Clear?
Okay.
Yes. So basically, this is what you're supposed to have done on that question. Then there's an element of distance there. So you just check what's going to be happening with the distance. When these two are happening, is it going to be polarization, or what is going to happen? You just see according to the distance. Clear?
Yes.
Yes.
Right. Then there was another question that I think that was not clear on this one. It was this one here. So I added this. So here you just work out with a negative and a positive charge. Then after sharing, then they've got the same charge, a positive. Then you answer the question. So you must just check from A to G, which one is true according to this. The one that is false,
Which
then you
one?
just leave it out. So you just looking for the ones that are true. So you just write A, B, or A, D, E, or whatever is true. That's it.
Okay.
Yes. Then I've got 2 minutes and 30 seconds left. Any other questions?
Mm.
Any other questions? Okay, so next week on Monday, what I'm gonna do, we're gonna go over the consolidation activity. All right, I think by then we'll have given everybody enough time to go over it. All right, then on Monday, okay, during the weekend on Monday, I'll post, we are done with electrostatics. So I'm gonna do a consolidation activity on electrostatics. So I'm gonna check past papers like the one that I've done for magnetism. Then I'm gonna post it, right, for you guys to practice exam questions. Then we're moving on to electricity. So electricity is the last topic for term 2. All right, so we're gonna go over electricity. That's the final topic for term 2. Then if we're still at home, then we'll move on to term 3. Right, but I'm not sure because I was speaking to Joshua. He's saying other people are not understanding, and there's a problem. I'll try to post the videos for the benefit of those who are not able to join us because of different reasons. Right. So I'm gonna be posting maybe some just to check on Google Classroom, maybe some activities for you to do. So that I check your understanding. There are people who are submitting work, I've seen, and I'm able to check, but I haven't been able to mark it, but I'll try this weekend so that at least people get feedback as to are they on track or not. Is that clear?
Yes, sir.
Right, so let's meet on Monday. I've got, I think, 30 seconds left. If anyone has a question, you can ask. Andy, what do you mean? Eh? Okay, all right, guys. Let's meet Monday.
Sir.
Right? Yes.
Same time.
All right,
Sir,
same time.
so-
Yes, same time. 11 o'clock.
Are we
Okay,
always
sir.
gonna be Monday, Tuesday? I mean Monday, Wednesday, Friday.
Yeah, Monday, Wednesday, Friday to give you a chance to do other things.